Right now, in remote corners of the world, a virus is spreading. It doesn't make headlines, it doesn't cause pandemics, but it kills over half of those it infects. It doesn't spread person to person, it doesn't create global outbreaks, but when it strikes, the survival rate can be as low as 38%. Welcome to the science of hantavirus, the rodent-borne killer most people have never heard of. First discovered in 1976, named after the Hantan River in South Korea where it was first identified, but it had been killing humans for centuries, unrecognized. Hantavirus is not one virus, it's a family of at least 21 different species, all carried by rodents, all potentially deadly to humans, each strain unique. The virus lives in rodent populations without harming them, perfect hosts, completely asymptomatic, but when humans inhale rodent droppings contaminated with virus particles, everything changes catastrophically. There are two major types of hantavirus disease, both deadly, both transmitted the same way, but they attack different organ systems. Let's start with the more common one, hemorrhagic fever with renal syndrome, HFRS, predominantly found in Asia and Europe, 150,000 to 200,000 cases annually. HFRS symptoms begin with sudden high fever, severe headache, back and abdominal pain. Then the kidneys start to fail, blood pressure crashes, internal bleeding begins. The kidneys stop filtering blood, waste products accumulate, blood pressure drops dangerously low, internal bleeding begins. This is why it's called hemorrhagic fever. Blood vessels rupture throughout the body. Mortality rate for HFRS varies dramatically by strain. Dobrava 12 to 15%, Hantan 5 to 15%, Seoul 1%, Pumala less than 1%. Medical care quality significantly affects survival outcomes. Now the second type, Hantavirus Pulmonary Syndrome, HPS, found primarily in the Americas. This one is far more deadly, 38 to 50% mortality rate.
HPS was first recognized in 1993, Four Corners region of the United States, Navajo Nation. Sudden cluster of mysterious deaths, healthy young people dying of rapid respiratory failure. Medical mystery. The early symptoms look like flu, fever, muscle aches, fatigue, chills, completely indistinguishable from 100 other infections. This is the danger. Then suddenly, 4 to 10 days after symptom onset, the lungs begin to fill with fluid, rapid pulmonary edema. The disease transforms catastrophically. This isn't pneumonia, this is capillary leak syndrome. The tiny blood vessels in the lungs become permeable. Blood plasma floods into the air sacs. The walls fail. The patient begins to drown, not from external water, from their own blood plasma. Internal drowning, suffocation from within. Oxygen levels plummet, blood pressure drops dangerously. The heart struggles to pump. Multi-organ failure begins cascading, all within hours. The body is shutting down. There is no antiviral treatment for HPS, no pharmaceutical cure, only supportive care, mechanical ventilation, oxygen supplementation, prayer, waiting to see if the patient's own immune system wins the battle. Now let's talk about transmission. How does this virus actually spread from rodents to humans? The path from nature to infection. The virus is excreted in rodent urine and feces. As these dry, they turn to dust. Any disturbance, sweeping, cleaning, renovation work, moving boxes stored in attics, sends virus particles into the air. One breath, that's all it takes. The infectious dose can be as low as a few virus particles. A single inhalation of contaminated dust is sufficient. Critical fact, hantavirus does not spread person to person. This is crucial information. No human-to-human transmission has been documented for nearly all strains. You cannot catch it from another person. The primary reservoir in North America, the deer mouse, Paromyscus maniculatus, perfectly adapted carrier, lives in rural and wilderness areas across the continent, abundant, widespread. In high-risk areas, 5 to 30% of deer mice carry hantavirus at any given time. healthy carriers, spreading virus throughout their entire lives, shedding it continuously. The incubation period, 1 to 5 weeks after exposure, usually 2 to 3 weeks. During this time, the patient feels completely fine, then symptoms explode suddenly. Who's at highest risk? People who work or recreate in rodent-inhabited areas, farmers, campers, hunters, construction workers, people cleaning out long-abandoned sheds and cabins. The 1993 Four Corners outbreak, 17 confirmed cases, 10 deaths, 59% mortality rate. The medical community was terrified. Unknown disease, rapid deaths. The outbreak was linked to increased rainfall that year, El Niño weather pattern. More rain meant more vegetation. More vegetation meant more rodents. More rodents meant more virus exposure. Ecological cascade. Since 1993, approximately 850 cases of HPS have been reported in the United States, over 300 deaths. The virus is still here, still spreading, still deadly.
How does the virus actually kill? Let's go microscopic. Journey inside the human body after infection. The biological warfare at cellular level. The virus targets endothelial cells, the cells lining blood vessels throughout the body. It infects them, doesn't kill them directly, but triggers a massive immune response. The real damage comes from immune overreaction. The immune system goes into overdrive, cytokine storm, too much inflammation. The blood vessels become leaky, plasma leaks into tissues. This is what causes all the deadly symptoms. The virus itself doesn't destroy your lungs, your own immune system does. Trying to fight the virus, your body creates collateral damage. It's a tragedy. You drown in your own immune response. Diagnosis is extremely difficult. Blood tests detect antibodies, but early diagnosis is nearly impossible. By the time antibodies appear in blood tests, the patient is often already critically ill. By the time antibodies appear in blood tests, the patient is often already critically ill, usually in the respiratory failure stage. The diagnostic window is tragically narrow. The disease progresses faster than diagnosis. Treatment in the ICU, mechanical ventilation supporting failing lungs. Careful fluid management, this is critical. Too much fluid worsens pulmonary edema. Too little causes shock. Doctors walk a tightrope. Some patients require ECMO, extracorporeal membrane oxygenation. An external machine takes over for the lungs completely. Blood is oxygenated outside the body. Last resort technology. Survivors often face long-term lung damage, reduced lung capacity, pulmonary fibrosis, permanent scarring, oxygen dependency. Recovery can take months to years. Some never fully recover. Prevention, the only real defense against hantavirus infection, because there is no vaccine, no antiviral cure, no pharmaceutical solution. Only prevention works. When cleaning areas with rodent infestation, ventilate thoroughly first. Wet down all droppings with disinfectant solution. Never sweep or vacuum. This aerosolizes virus particles. Wear protective gear, gloves, N95 respirator or better. Use wet cleaning only. Double bag waste. These simple steps can save your life. Knowledge prevents infection. Seal your home against rodent entry. Even a hole the size of a dime is large enough for a mouse to enter. Steel wool and caulk. Prevention starts with exclusion. Store food in rodent-proof containers, metal or very thick plastic, never cardboard. Remove outdoor food sources. Bird feeders and fallen fruit attract rodents. Climate change is expanding hantavirus range, rodent populations moving into new territories, warmer temperatures allowing year-round breeding. More rodents means more virus, more exposure risk. One exception to the no transmission rule, the Andes virus in South America has demonstrated rare person-to-person transmission, the only hantavirus strain documented to spread between humans.
The mechanism for Andes person-to-person transmission remains unclear. Close contact appears required, possibly respiratory droplets. But even Andes virus transmission remains extremely rare, most cases still rodent to human. Vaccine development efforts continue, but the hantavirus vaccine faces significant challenges: multiple virus strains, low commercial incentive for pharmaceutical companies, rare disease status limiting market. Some experimental vaccines have shown promise in animal studies, protection demonstrated, but human trials remain years away. No approved vaccine exists anywhere in the world. Historical cases. Hantavirus has likely killed thousands throughout history, only recognized as a distinct disease in the 1970s. How many victims went completely undiagnosed? How many deaths were attributed to other causes? Modern surveillance has improved significantly, but underdiagnosis still occurs regularly. Mild cases mistaken for common flu, severe cases in remote areas never tested, underreporting likely. Hantavirus in popular culture. The 1995 movie Outbreak was inspired partly by hantavirus and Ebola. Public awareness increased briefly, then faded away. The virus particle itself, roughly 100 nanometers in diameter, spherical in shape, wrapped in a lipid membrane envelope. Surface proteins critical for attaching to and entering human cells. The virus is fragile outside its host, killed easily by common disinfectants, destroyed rapidly by sunlight and UV radiation, cannot survive long in dry air conditions. This is why proper wet cleaning works. Genetic analysis reveals hantaviruses co-evolved with their rodent hosts for millions of years, perfect adaptation, evolutionary relationship spanning deep evolutionary time. Each rodent species carries its own specific hantavirus strain. Deer mice carry Sin-Nombre virus, rice rats carry Bayou virus, cotton rats carry Black Creek Canal virus, one-to-one species-specific relationships. Why doesn't the virus harm its rodent host? Millions of years of evolution created immune tolerance. The rodent immune system recognizes the virus but doesn't attack it. Perfect evolutionary truce. But when the virus jumps to humans, a species it never co-evolved with, there is no tolerance established, only catastrophic immune response. The immune system sees a threat and overreacts. The future of hantavirus threat: climate change expanding range, habitat destruction forcing human-rodent contact, urban sprawl into wilderness areas. Cases will likely increase. Hantavirus, a virus that evolved perfectly to live peacefully with rodents for millions of years, but when it encounters humans who venture into wilderness, who clean old buildings, who disturb rodent nests, it becomes a killer. Silent, efficient, deadly, and still claiming victims every single year.